some of the answers to the questions from exercise 3A. So this is question 6, so D, E and F I thought I'd go through. So it's simplify each of the following expressions. Now the first one, D, is sine squared x on cos x plus cos x. You have to simplify that expression. Now what I would be doing is I'd be looking at the three rules that you know for this section, which is your, the classic sine squared x plus cos squared x equals 1. The 1 plus cot squared x equals cosec squared x, and 1 plus tan squared x equals sec squared x. Now when I look at this question, what I'm thinking is there's a sine x on a cos x, so I'm thinking there's some kind of tan thing going on. But then I look at my rules and I can see that I'd really like to have a tan squared x going on here, which I'm a little bit short on because I don't have a cos squared x here. So what I'm going to do with this is I'm going to actually effectively manufacture so that I have a cos squared x underneath. What I'm going to do is I'm going to divide everything by cos x. So what that does is it does actually change everything a little bit, because you can't just divide everything by cos x and move on. What you have to do is then do the opposite. So it's effectively like saying 1 plus 2. If you wanted to make that a bit different, you could divide them both by 2. Okay, but that changes this expression. So if you multiplied by 2, it's like you've done nothing. You've still got what you started with. Okay, so that's what I've done here. I've just put another cos on the bottom of both of those expressions. So this makes it a cos squared now on the bottom here and puts a cos under here. And then I put the cos out the front. So it's a really common trick that they will use to make you, it's effectively forcing a factorizing, like you're manufacturing factorizing, so using that kind of method. So once you've got that now, what I'm going to do is just simplify that down a bit. So I've got cos x out the front, and you can see here that the sine squared x on cos squared x would be tan squared x, and cos x on itself is 1. And now looking over, can you see that matches this side of the expression? So I'm going to just say here using, and I'll just rewrite it. So it's tan squared x plus 1, it's exactly the same thing, equals sec squared x. We now have, our expression is cos x, and inside the bracket, we're just going to replace the tan squared x plus 1 with sec squared x. Now remember what sec squared x is? It's 1 on cosine of x, and because this is sec squared, it's cosine squared of x. So what you can do is cancel. When I'm cancelling things with powers, because one of those cos x's will cancel all of that, I just cross the little power out. So all I'm left with is 1 over cos x, which is sec x. So what you've shown, therefore, is that what you started with, sine squared x on cos x plus cos x, actually all boils down to sec x. Okay, so that's that first one. So I'll just draw a box around that one. That's D. For the next expression, E, and I'll write this one down. Oops. E is sine to the power of 4x. Oops, that looks like 4x. Let's get rid of that. So sine to the power of 4x minus cos to the power of 4x. Now a really common thing that you'll see a lot of in Spec is using the idea of difference of squares. So for example, if you had, and I'll just write here, so difference of squares. So if you have two things that are perfect squares, so for example, if you had x squared take away 9, we know that factorizes into x take 3 and x plus 3. That's a difference of squares. And actually here, you might be thinking, I don't actually have squares. But you do have things that are squared, they're just hiding inside powers of 4. Also remember that something like x to the power of 4 can be written as x squared, and all of that is squared. Okay, so you might be able to stop the video now and have a go at that, because that's the sort of the main trick here. So sine to the power of 4x minus cos to the power of 4x equals, I'm going to take what is in there as actually a squared sine. Okay, so sine squared x, and that's all squared. Take away cos squared x, and that's all squared. So that's using that idea there that x to the power of 4 is x squared squared. Okay, now difference of squares, we've got, I just change my pen back. Okay, we're looking at the example here. So what you're imagining here is that you've got x squared minus 3 squared. So what's in the bracket here, the x, goes into these brackets. So in our example, what's in the bracket here, we're going to have two brackets, yeah? What's in the bracket here, the sine squared x, is going to go into both brackets. And then this 9 is actually 3 squared. So that 3 is what goes into the other parts of the bracket. So that would be this cos squared x. So cos squared x goes into the other part of the bracket, and the signs are different, opposite signs. So that's difference of squares for something that actually doesn't look like difference of squares, but is hidden. It's a kind of like a camouflaged one. Okay, so once you identify this big trick here, which is a common one, even powers hiding squares, then you're okay with that. So from there, what we're going to do, I'm just going to copy this and use it on the next page so we can continue on with it. Now hopefully what you've noticed at this point is something that's very familiar, which is this part here. So we know that sine squared x plus cos squared x equals 1. We also know that from this you could rearrange this as well, and you could solve for either cos squared x or sine squared x. I'm just going to solve for sine squared x because it's first. It doesn't make any difference. So what we know as well here is what sine squared x can be replaced with. So looking at what we have, we know that this part here is equal to 1, and we know that we can do a replacement or a substitution on this part. So what we've got now, I'm going to substitute out the sine squared x with this. Okay, so instead of sine squared x, I'm going to write 1 minus cos squared x in its place. Okay, and then we've got the rest of it, and actually I'll do that in green so you can see where the substitution is. So this is the underlined part. I've replaced that. The other part's still there. And then in the bracket, I'm replacing all of that with 1. Okay, so now because 1 multiplied by something is 1 multiplying anything is just itself, we've now got 1 minus, there's 2 cos squared x. Now because of this chapter, we haven't, in 3A, we didn't actually know the double angle formulas. That would have been the end here. But with this, you could leave it in that form. But what we will do, here's it's double angle formula, is we'll actually go to double angle formula because we've now done that. So if you have a look at your double angle formula on your formula sheet, you'll remember that cos of 2x is actually 2 cos squared x minus 1. So negative cos of 2x equals, change both the signs. And that looks just like that. They're exactly the same. So this particular question, if you hadn't known about double angle formula, you would have stopped at this point. But because we do know that the double angle formula does look like that for cos 2x, we know that what we started with, which was sine to the power of 4x minus cos to the power of 4x, that's going to be equal to this thing here, 1 minus 2 cos squared x. And if you wanted to go further using the double angle formula, it's actually cos of 2x, but it's the negative of that. So negative cos of 2x. Okay, last one in that section is f, which is tan cubed x plus tan x. Now, straight away you should think to yourself, factorise the common thing out, which we're going to do. So tan x is common. You're now left with tan squared x plus 1 inside the bracket. And if we go back here, you can see tan squared x plus 1, sweet, is sec squared x. And that's it. That one's a really quick one. And I should multiply by tan x. And that's it for that one. There's actually not much more you can do with that. So that's its final answer. So it's a really short one compared to the one that we had before that was quite long. So you can see that the first two there were quite long, and the third one was nice and short. So the last one that I wanted to go through was question 16. So I've put that up here. This is the question here. So we've got, if x equals sec theta minus tan theta, prove that x plus 1 on x equals 2 sec theta, and also find a simple expression for x minus 1 on x in terms of theta. Now there's a lot going on here. So with this one, what you'd want to be looking at is, first of all, that is what you keep in your head. Okay, and you've got an x going on, which is just all this stuff, and you've got a 1 on x going on as well. So effectively what you've got here is a substitution. So instead of writing x in those places, you're going to actually write the sec theta minus tan theta in place of x plus 1 on, and you'll put the sec theta minus tan theta underneath. Okay. Now this is one of those instances where you want to get a common denominator. Now we looked at this in class. So the idea with common denominators is if you have a whole number like 3 plus, say you have 3 plus a half, and you want to get that whole number over this new denominator, what you do is you divide by the denominator that you want, but you also times by the denominator that you want. And what that does is effectively means you've done nothing to this number. Okay, so for this example, what we're going to have to do is take what we have there on the left side. So we've got sec, I'm just going to write this a bit smaller, minus tan theta. We're going to take the denominator, I'm going to do this in light blue just like I did here. Take that denominator, which is sec theta minus tan, sec theta minus tan theta underneath, and then also, let's fix that one up, put that out the front as well. I'm going to put brackets around it, and I'm also going to put brackets around this too, so we don't lose track. And then we've still got plus 1 over sec theta minus tan theta. Now the nice thing here is that we can now put everything, okay, over the top of the one denominator. So we now have, I'm actually going to expand this too as I'm going, so you've got sec squared theta minus tan theta sec theta, oops, then these two, minus tan theta sec theta, and then these two, plus tan squared theta, and then you've still got that plus 1, that 1 from there. So that's the whole top line, and underneath you've got sec theta minus tan theta. So always keep your eyes on the prize. We're trying to show that all of this will actually break down into this. So that means we really want to get rid of tans here and try and just get sec going on. So let's combine things that we have. So we've got sec squared theta. You might identify here you've got tan squared theta plus 1. You can see here tan squared theta, or tan squared x plus 1, is sec squared x. Let's use that rule. And these two here, these will combine together. So this is minus 2 tan theta sec theta. This part here is this. So let's do a replacement. So we're going to put plus sec squared theta here. And again, this is all over sec theta minus tan theta. With this again, you've got two things that are the same, so let's group them together. Sec theta squared, there's 2 of them. And there's also 2 of these tan theta sec thetas going on. Now, excuse me, at this point, there should be something jumping out at you to do. And that's to take out the common factor. So let's grab this. I'll put this on the next page. Whoa. Grab this and put this on the next page. We're nearly done. I'll actually just bring the question along as well, so we can see where we're trying to get to. So you can see here we're going to factor out the 2 and one of the secs as well, because that's common. So we've got 2 sec theta. That leaves me with a sec theta still in the bracket, minus a tan theta. Check it out, what the bottom line is, sec theta minus tan theta. Oh, so lovely, so beautiful. Because now you can cancel all of that out. And all you're left with is 2 sec theta. So we can actually say here equals 2 sec theta as required. So we got to where we wanted to get to. So with this question, it was all about identifying, okay, this is x, this thing here, putting that x into the expression that they're providing you with, and then trying to get to 2 sec theta. Okay. It also says here, find a simple expression for x minus 1 on x in terms of theta. And you would do that question exactly the same way as the one that I've just done. So that's a really good example for you to just try on your own. So remember that with this question we had what x is. It's the same x that you'd be substituting in here and here. And then you're going to be trying to get x minus 1 on x and seeing what you get. So you'll work through it exactly the same way. Try and again get everything over a common denominator. Factorize things out. If you can, look over at your rules here and try and identify which rule you should be using. Oops. Okay, to try and get rid of or simplify things in your expression. I can tell you as a hint before you get started here, it's going to be just as simple as an answer as the one that we got here. So we got 2 sec theta for this one. Have a go, definitely, to just test that you follow this. Try x minus 1 on x and see if you can get a simplified form for that expression.